Okay, I want to take a look at this problem because it has a lot going on with it, and so I wanted to go through each step. First of all, we're working with the binomial distribution, and we know P is 0.60 and N is 50. In the first part of this problem, A, we want to find the mean and the standard deviation. So let's go ahead and do part A. So they gave us N, which is 50, and P, which is the probability of success, is 0.60. Let's go ahead and find Q, because remember, binomial distributions, we have N, P, Q. Q is the probability of failure. Remember, these P and Q are your two probabilities. They have to add up to 1. So 1 minus 0.6 would be 0.4. So let's find the mean. We know the formula for mean of a binomial distribution is N times P, and N is 50, P is 0.6, so the mean is 30. Now let's find the standard deviation. The formula for the standard deviation of a binomial distribution is the square root of N times P times Q. N is 50, P is 0.6, and Q is 0.4. So the standard deviation is the square root of 12, which is 3. I think they wanted us to round to 3 decimal places. So let's highlight our answers here, because for this problem, these two values will be used when we're doing probability. You'll need to know those two. Okay, so going to the second part of this problem. We want to know the probability for B. What is the probability of exactly 33 successes? Okay, in this chapter, in the PowerPoint and in the e-text, they're going to mention something about using the normal distribution to approximate the binomial. Now, you can only use the normal distribution if these two rules are true. N times P is greater than or equal to 5, and N times Q is greater than or equal to 5. Both of these have to be true, and then you can use the normal distribution with a few modifications, which we'll talk about. So remember, N, we already said N, we know what N times P is. That's just your mean. I'm just plugging in my values. 30 is definitely greater than or equal to 5, so that's good. But for the second one, we're going to do 50 times 0.4, which is Q, and that is 20, and 20 is definitely greater than or equal to 5. So we will use the normal distribution to approximate the binomial distribution. So that is really important to note. So there are some adjustments that we're going to have to make, and it's basically, let's look at our probability here that we're trying to find, and then we'll go through that again. Probability of exactly 33 successes. So the probability of exactly 33 successes. Okay, so I've gone to chapter 6 to the slides, and this is slide 40. And this is showing you about how we're not just going to go look up on a table, the normal distribution table, x equals 9, or find the z-score for exactly 9. What we're going to do is we're going to use an interval for our value. Okay, of course, our value is not 9. Our value is 33. But what I want to show you is we're going to use the interval. And this interval is found using what we call the continuity correction factor. So what you're going to do is you're going to take your value that you're trying to find and you're going to add and subtract 0.5 from it. So this is called CCF, continuity correction factor. So what we're going to do, I'm going to move this over a little bit, is to find the probability that x is equal to 3, we're going to add 33 plus 0.5 and 33 minus 0.5 to get our interval. So if we do that, we're going to get 33. Let's start with our smaller value here. 33 minus 0.5 would be 32.5, and 33 plus 0.5 would be 33.5. So we're going to find the interval of x in between these two values. So basically what we're going to have to do is, this makes it more, this part the most complicated in the problem. What we're going to do is find the z-score for both of these values. So remember the z, and we're doing the normal now. We're working it like the normal probability or normal distribution. So we're using the z value for both of these. So double work now because we're using that interval. So x would be 32.5 here, and x would be 33.5 here. And then we know the mean was 30, and we calculated the standard deviation above as 3.464. That's what I highlighted at the top. So here we would have 30 and 3.464. So you could go ahead and calculate the z value if we were going to do that. But if you keep reading in the problem, it does not want you to manually calculate the z value, but that is how you would. So what instead this problem wants you to do, and why it makes it more confusing, is it wants you to go into Excel and find these two probabilities. So the way you do that is, I'm going to just delete all these numbers so you can see it a little bit better. Is there's a formula, and it's equals norm dot dist, and what you do is you put in your x value. So our first x value that we had, I believe, was 32.5, then comma, put the mean, which is 30, and then this comma, standard deviation is 3.464, and then we do comma want it to be cumulative, just like we do in the table when we look it up. So 0.844854, and the other probability, we're going to do equals norm dot dist, and we're going to do 33.5 this time, and everything else is going to be the same, mean, standard deviation, and then true. Okay, so we have these two values here. Now here's the deal with these two values. Basically what you're doing is you have a standard curve here. You know the mean is 0 now because we've standardized it, and I know that these two numbers are above the mean, so I'm just going to guess where they are. Let's just say there's one right here and one right here. And we know the probability of the first value, the smaller value, is going to be all the way up to this point. And we found that probability. That was our first value, and it was let's see. It was this one, 0.843846. So 0.8438. So this probability here is 0.8438. Then what we did was we looked up the probability for the bigger value, which is going to include all of the 0.8438, but a little bit more than that. And that probability was 0.8449. So 0.8449 includes everything green. But what we want is the in-between right here. So what we can do is we can take what we know all from here all the way over, which is the 0.8449, and we can subtract from here all the way over, because that's what we don't want. We only want the in-between, so you subtract the 0.8438. So basically, when you have an interval and you want to know in between, you take the largest and you subtract out the smallest. Let me say that again. When we want to know the probability between two values, you take the larger probability and subtract the smaller. And when you do that, you get, let me pause it. Well, let me look back because it's good for y'all to see me make mistakes here. One of my numbers is off. So let's go back and see what I did here. 32.5. Okay. Oh, I see. See, I put it in wrong right there. My standard deviation should have been 3. So that is the problem, which means I put the numbers in wrong here, because the number that should have been here, the number that should have been here was the 0.8438, and the number that should have been for the yellow highlighted was 0.7648. So you can see that I mess up too a lot, actually. And normally sometimes when I mess up, I start over, or I pause it and rewind it and edit it. But I think it's good and encouraging to see that Miss Horn messes up a good bit. 8438 minus 0.7648. And you should get 0.079. So the probability that x equals 33 is 0.079. And I will finish this problem in the next video.